Hello, in this lecture we will find out the value of line segment X using three different methods. In the drawing we have a right triangle, triangle ABC, angle DAC equals to 45 degrees, angle ABC equals to 90 degrees, side AB of triangle ABC equals to 6 units, and side DC equals to 10 units. And we want to find out the value of line segment AD, that is actually X. Okay, so we'll start with the first method. In the first method, we will do a construction. We will extend line segment AD by a straight line. So here we'll create long straight line. And from point C, we'll draw perpendicular to the extended AD. So this angle will be equal to 90 degrees, and this angle will be also equal to 90 degrees, and we will define the touching point of the perpendicular from point C and the extended AD as point E. And here we know that in every triangle the sum of the angles is equal to 180 degrees. So we will focus on the right triangle, triangle AEC. In this right triangle, the sum of the angles must be equal to 180 degrees. So write it down. In the right triangle, triangle AEC, the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle, triangle AEC? We have here 45 degrees. We have here, this angle is equal to 90 degrees, plus this angle that is actually the missing angle, that is angle ECA. In total, the sum of those three angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. Okay. I'll repeat again. The sum of three angles in triangle, the right triangle, triangle AEC must be equal to 180 degrees. So here we will subtract 90 degrees from this equation, and we'll get that 45 degrees plus the side of angle ECA equals to 180 degrees minus 90 degrees. It is 90 degrees. We will subtract 45 degrees from this equation, and we'll get that the missing angle, angle ECA, is equal to 90 degrees minus 45 degrees. It is 45 degrees. So here, this angle equals to 45 degrees, angle ECA equals to 45 degrees. And we have also the rule that in front of equal angles in a triangle, there are equal sides. So in front of those two equal angles there must be an equal sides. That is to say, side AE must be equal to side EC. AE must be equal to EC, but A equals to X. Okay, but first of all, we will define line segment DE as Y. So actually, AE equals to X plus Y. A equals to X plus Y. And from this equation, X plus Y equals to A equals to EC, we derive that EC is also equals to X plus Y. EC equals to X plus Y. You can write here that EC equals to X plus Y. Okay. So here we have vertex angles that are equal to each other. Those two angles are defined as vertex angles and they are equal to each other. So if we define angle ABD as alpha, then angle CED will be also equal to alpha. And therefore angle BAD equals to 90 degrees minus alpha. And angle ECD also equals to 90 degrees minus alpha. So actually, if you focus on the right triangles, triangle ABD, and the right triangle, triangle EDC, those two right triangles are similar to each other. The green right triangles are similar to each other. Why? Because they have the same angles. Both triangles have angle alpha. Both those two triangles have angle that is equal to 90 degrees minus alpha. And both those two triangles have angle that is a right angle. It is equal to 90 degrees. So therefore, we can conclude that the right triangle ABD is similar, the right great triangle ABD is similar to the right triangle EDC according to angle similarity rule. Okay? I'll write it down. The right triangle ABD, the right great triangle, is similar, this is the sign of similar, to the right triangle DEC, according to angle similarity rule. And from the fact that those two right great triangles are similar to each other, we'll conclude that the following relationship exists between their sides. We'll conclude that AB over EC is equal to BD over DE. I'll repeat again, from the fact that the two green right triangles are similar to each other, we conclude that AB over EC equals to BD over DE, and also that AD, and it is equal also to AD over DC. Okay? So from the fact that the two green right triangles are similar to each other, we conclude that the following relationship exists between their sides. AB over EC equals to BD over DE equals to AD over DC. Okay? And we know that AB equals to 6 units, so we'll substitute AB by 6 units. EC equals to x plus y, so we'll substitute EC by x plus y, and it is equal to BD is equal to BD, we'll leave it as it is, BD over DE, DE equals to y, and it is equal to AD is equal to x according to what is given us in the question, and DC equals to 10 units. So in conclusion, we found out that according to equation number 1, 6 over x plus y equals to BD over y, that is equal to x over 10. What is the value of BD? So we'll focus on the right triangle ABD. In the right triangle ABD, according to the Pythagoras theorem. Pt is abbreviation for Pythagoras theorem. You will get that AB squared plus BD squared equals to AD squared. AB is 6, so AB squared is 6 squared, that is 36, plus BD squared is the missing variable, and it is equal to AD, that AD squared, it is x squared. We'll substitute 36 from this equation and we get that BD squared equals to x squared minus 36. We will take a root out of this equation and we get that BD is equal to the square root of x squared minus 36. Okay? Now we can substitute BD in equation number 1 by square root of x squared by 36. We will do it now and we get that according to equation number 1, six over x plus y is equal to BD. BD is square root of x squared minus 36 over y, and it is equal to x over 10. Here we create the first equation. The first equation will be 6 over x plus y equals to x over 10. Here we cross multiply this equation, equation number 1, and we get that 6 times 10 is 60, and it is equal to x times x plus y. We will open the brackets here and we will get that according to equation number 1, 6 equals to x squared plus xy. X squared plus xy. We will subtract x squared from this equation, equation number 1, and we get that 60 minus x squared equals to xy. So according to equation number 1, we found out that xy equals to 60 minus x squared. In the next step, we create equation number 2 from this long equation. Here, square root of x squared minus 36 over y equals to x over 10. Here we will cross multiply equation number 2, and we get that according to equation number 2, 10 times square root of x squared minus 36 is equal to xy. So we have two different expressions for xy. Now we will create equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. So equation number 3 states that xy according to equation number 1 that is actually equals to 60 minus x squared must be equal to xy according to equation number 2 that is actually equals to 10 times square root of x squared minus 36. Here we will square both sides of equation number 3 and we get that according to equation number 3 60 minus x squared equals to 10 squared, that is 100, and here the square cancels the root and we left only with x squared minus 36. So here we open the brackets in this side of equation number 3 and we get that according to equation number 3 60 we'll open the brackets on both sides of equation number 3 and we get that here it is 60 squared. 60 squared is 3,600 plus x squared times x squared is x to the power of 4 minus 2 times 60 times x squared. It is equal to, we'll open the brackets here, 100 times x squared minus 300 minus 3,600. Here we will add 3,600 to this equation and we will get that according to equation number 3 3,600 plus 3,600 is 7,200 plus x to the power of 4 minus 120 x squared equals to 100 x squared. Here we will subtract 100 x squared from this equation and we'll get that according to equation number 3 x to the power of 4 here we subtract 100 x squared from this equation, equation number 3, minus 120 times x squared minus 100 x squared is minus 220 x squared plus 7,200 equals to 0. Minus 220 is minus 180 minus 40, so we'll write down that minus 220 x squared equals to minus 180 x squared minus 40 x squared. Okay, and we get that according to equation number 3, x to the power of 4 minus 180 x squared minus 40 x squared plus 7200 equals to 0. Here, from those expression and from this expression, we will take x squared as a common factor. From this expression, we will take x squared as a common factor, and from this expression, we will take minus 40 as a common factor. And here we will get that according to equation number 3. So here we take x squared as a common factor. Inside the brackets we will have x squared minus 180. And from here we will take minus 40 as a common factor. So inside the brackets we will have x squared minus 180, because minus 180 times minus 40 equals to 7,200, and it is equal to 0. So here we take x squared minus 180 as a common factor, and we get that according to equation number 3. So we took x squared minus 180 as a common factor. Inside the brackets from this expression, what is left is x squared. And for what is left from this expression after we took x squared minus 180 as a common factor, what is left is actually minus 40. So in conclusion, we found out that x squared minus 180 times x squared minus 40 equals to 0. Here we will have two solutions that are possible for x. The first solution is that either x squared minus 180 is equal to 0, or the second solution is that x squared minus 40 is equal to 0. So we'll start with the first solution. According to this equation, we will get that x squared is equal to 180, and as x is equal to the square root of 180. 180 is 36 times 5. Okay? So we got that x squared equals to square root of 36 is 6, and inside the root we have square root of 5. 6 times square root of 5 is equal to 13.416. That is greater than 10. And the second solution that is possible for x is that x squared minus 40 equals to 0. That is to say, x squared equals to 40. We take a root out of this equation, and we get that according to the second solution, x equals to the square root of 40. The square root of 40 is 4 times 10. And the square root of 4 is 2. So, in conclusion, we got that the solution for x is 2 times square root of 10. 2 times square root of 10 it is equal to 6.32. It is equal to 6.32, that is less than 10. Okay, we have here two solutions that are possible for x. Either x equals to 13.416 units or x equals to 6.32 units. One solution is greater than 10 and the second solution is less than 10. Okay, so here so I draw the triangle ABD. I will draw triangle ABD with triangle ADC, and we'll find out if those two solutions are correct or not. So here we have triangle ABD. This is a right triangle. This angle equals to 90 degrees. This is triangle ABD. We will define this angle as angle theta. This is angle alpha. And we also have triangle ADC that is adjacent to triangle ABD. We know that AD equals to x. We know that angle DAC equals to 45 degrees. And what is the value of angle ADC? Angle ADC this angle ADC. Angle ADC is an exterior angle of triangle, the right triangle, triangle ABD. And we actually have a rule that states that an exterior angle of a triangle, that is to say angle ADC, that is an exterior angle to the right triangle, triangle ABD, is equal to the sum of the two interior angles that are not adjacent to it. I will read the rule again. According to the rule that I wrote down, an external angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So the value of this external angle, I will repeat again, that angle ADC is considered as an external angle in relation to the right triangle, triangle ABD. I repeat again, angle ADC, this angle is an external angle to the right triangle, triangle ABD. So according to the rule that is stated, the value of this external angle, it is equal to the sum of the two interior angles of triangle ABD that are not adjacent to it. Angle alpha is adjacent to this angle ADC. Those two angles are adjacent to each other. So the two other interior angles that are not adjacent to the external angle ADC are those two angles, theta and 90 degrees. Therefore, that is to say, it will be equal to the sum of the two interior angles that are not adjacent to it. That is to say, it will be equal to 90 degrees plus theta. Okay? And we know that the sum of the angles in triangle ADC, this triangle must be equal to 180 degrees. So here we have one angle is 45 degrees, plus this angle that is 90 degrees, plus theta, plus the size of this angle that is actually angle ACD. Angle ACD, in total they must be equal to 180 degrees. So here we'll subtract 90 degrees from this equation and we'll get that 45 degrees plus theta plus angle ACD equals to 180 degrees minus 90 degrees, it is 90 degrees. We'll subtract 45 degrees from this equation and we get that angle theta plus angle ACD, they are equal to 90 degrees minus 45 degrees, it is 45 degrees. We will subtract theta from this equation and we get that angle ACD is equal to 45 degrees minus theta. So this angle equals to 45 degrees minus theta. So actually we found out that the smallest angle in triangle ACD is this angle that is equal to 45 degrees minus theta. And we have another rule. The rule states that in front of the smallest angle in the triangle, in front of the smallest angle in the triangle, there is the shortest side. There is the shortest side. Okay, repeat on the word that I hold down, that in front of the smallest angle in the triangle there is the shortest side. Okay, so, and because of the fact that this angle is the smallest angle in this triangle, triangle ADC, therefore in front of it there must be the shortest side. So X is the shortest side in triangle ADC. But we know that DC equals to 10 units and X is the shortest side. That is to say X must be less than 10 units. So according to the rule that I stated, X must be less than 10 units because it is the shortest side in this triangle ADC, and we have a side that is equal to 10 units, and because of the fact that it is the shortest side, it must be less than 10 units. So X is less than 10 units, and here, according to the question, to the two answers that we got, one answer is X equals to 6 times square root of 5, that is equal to 13.416, that is greater than 10. So X must be less than 10 units, so this answer is the correct answer, and we left only with the second answer, that X equals to 2 times square root of 10, that is actually 6.32 units, that is less than 10 units, and that is the correct answer to the question. X equals to 6.32 units. Okay. And that is actually the answer to the question, that the value of line segment X, or the length of line segment X, is equal to 10 times square root of 2 times square root of 10 units, that is about 6.32 units. That is the answer to the question. So, in the next step, I will present to you the second method to find out the value of line segment X So here we'll do a construction. From point D, we'll draw a straight line on AC in such a way that the angle that will be created here, in such a way that this angle AED will be equal to 45 degrees. Okay, so we made the construction. From point D, we draw a straight line on AC in such a way that angle AED, this angle equals to 45 degrees. And according to the, so if we focus on triangle ADE, first of all, we know that in front of equal angles in the triangle there are equal sides. So if AD equals to x, then DE must be also equal to x. And here we know that the sum of the angles in any triangle is equal to 180 degrees. So here, if we focus on triangle ADE, and on triangle ADE, the sum of the angles must be equal to 180 degrees. This triangle so here we have 45 degrees plus 45 degrees plus the size of the third angle, that is angle ADE. In total, the sum of those two three angles must be equal to 180 degrees. We will subtract 90 degrees from this equation and we will get that angle ADE, the missing angle, equals to 180 degrees minus 90 degrees. It is 90 degrees. So we found out that this is a right angle. Angle ADE is a right angle. In the next step, we will do another construction. From point E, we will draw perpendicular to BC. From point E, we will draw perpendicular on BC. So this angle equals to 90 degrees, and this angle equals to 90 degrees also. And we will define the touching point of the perpendicular from point E and BC as point F. And we actually know, it is given us in the question, that triangle ABC is a right triangle, so BC is one side of a right triangle. BC is a side of a triangle. It is absolutely a straight line. BC is a straight line. Okay. And we know that BC is a straight line. So if we define angle BAD as theta, then this is a right triangle. Triangle ABD is a right triangle, therefore angle BDA must be equal to 90 degrees minus theta. Okay, this is very simple, I will not explain it. And if we focus, so we know that BC is a straight line. Okay, BC is a straight line, so we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, then on the upper side of the straight line BC at point D, the sum of the angles must be equal to 180 degrees. So which angles we have on the upper side of BC, of the straight line BC at point D? We have here 90 degrees minus theta. And we also have here angle that is equal to 90 degrees. And we have the missing angle that is actually angle EDF. Angle EDF. In total, the sum of those two angles must be equal to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Okay. And 90 degrees plus 90 degrees is 180 degrees. So we have 180 degrees on both sides of the equation. 180 degrees will get cancelled. And we left only minus theta plus angle EDF. It is equal to 0. We will add theta to this equation. And we will get that the missing angle EDF. Angle EDF is equal to theta. Okay. The missing angle EDF equals to theta. So here we have 90 degrees. Angle EF in triangle DEF, we have this is a right angle. So the sum of those two angles must be equal to 180 the sum of those two angles must be equal to 90 degrees, because 90 degrees plus 90 degrees is 180 degrees. That is the sum of the angles in a triangle. Okay, so we know that this angle plus this angle, the sum of those two angles must be equal to 90 degrees. Therefore, the sum of this and the value of this angle will be equal to 90 degrees minus theta. Okay. We actually found out that all the angles in those two green triangles are equal to each other. Both those two green right triangles have one angle that is equal to theta. Both those two green right triangles have one angle that is equal to 90 degrees minus theta, and both those two green right triangles have a right angle that is equal to 90 degrees. And we also know that AD is equal to DE, that is equal to X. Okay, so I write it down that it is very easy to prove that the two green triangles can go into each other according to angle side angle rule. We will focus on the two green triangles, triangle ABD and triangle EDF. Angle BAD, this angle is equal to angle EDF, this angle, and both angles are equal to theta. AD equals to DE equals to X. AD equals to DE equals to X. And this angle, it is angle ADB. Angle ADB is equal to angle DEF. And both angles are equal to 90 degrees minus theta. So we actually proved that those two triangles can go into each other. Triangle ABD congruent, this is the sign of congruent to triangle EDF according to angle side angle rule. Okay, we have this side is equal to this side, they are both equal to x, and the two angles that attached to this side corresponding equal to the two angles that are attached to this side. Actually, all the angles are equal, but this is the angle, side angle rule. Okay, so we proved even more than what we have to prove, because we proved that all the angles of those two triangles are equal to each other. So we actually proved the triangle ABD is congruent to triangle EDF according to angle side angle rule, and from the fact that those two triangles congruent to each other, we will conclude hence that AB is equal to DF. AB is equal to DF according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles congruent to each other, therefore the corresponding sides, that is to say AB and DF, will be equal to each other as corresponding sides in congruent triangles. So AB equals to DF, but AB equals to 6. AB equals to DF, but it is given us the equation that AB equals to 6. So from this equation C equals to AB equals to DF, we will derive that DF is also equals to 6. DF is also equals to 6 units. And here it is given us the question that DC equals to 10 units. DC equals to 10 units, so DC minus DF DC minus DF equals to FC. I'll repeat again, DC minus DF equals to FC. DC is 10 units, DF is 6. So FC equals to 10 minus 6, that is 4. FC equals to 4 units. Here FC equals to 4 units. And we define BD as Y, and because of the fact that those two triangles can go into each other, BD is equal to EF. BD is equal to EF according to the rule that corresponding sides in congruent triangles are equal to each other. Those two triangles can go into each other, therefore the corresponding sides, that is to say BD and EF, will be equal to each other. But BD equals to Y according to our definition, so from this equation Y equals to BD equals to EF, we will derive that EF is also equals to Y. EF equals to Y. Okay. In the next step, we'll prove that the big right triangle, triangle ABC, is similar to the small right triangle, triangle EFC. Why those two triangles are similar to each other? First of all, so write it down, triangle ABC and triangle EFC. We'll focus on those two right triangles. First of all, angle ABC in triangle ABC equals to angle EFC in triangle EFC, and both angles are right angles, they are equal to 90 degrees. Second, they have a common angle. This angle is a common angle. So angle BCA is equal to angle FCE and it is a common angle, it belongs to both triangles. And finally, angle FEC or angle BAC, angle BAC is equal to angle FEC according to third angle theorem. Third angle theorem. Actually, the third angle theorem states that if two angles in one triangle can go into two angles in another triangle, then the first pair of angles must also congruent because they are complementary to 180 degrees. Okay, so we proved that all the angles in the right big triangle ABC can go into all the angles of triangle FEC. Therefore, we will conclude that the right triangle ABC, the right big triangle ABC is similar. This is the sign of similar to the right triangle EFC according to angle similarity rule. Okay, those triangle ABC is similar to triangle EFC according to angle similarity rule, and from the fact that those two triangles, right triangles, are similar to each other, we will conclude that the following relationship exists between their sides. We will conclude that AB over BC equals to EF over FC. Okay. AB equals to 6 units, BC equals to DC plus BD, that is 10 plus Y. EF equals to Y and FC equals to 4. Okay, so in conclusion, we found out that according to equation number 1, 6 over 10 plus Y equals to Y over 4. We will cross multiply equation number 1 and we get that 6 times 4 is 24 and it is equal to 10 plus Y times Y. We will open the brackets here and we get that 24 equals to 10y plus y squared. We subtract 24 from this equation number 1, and we get that according to equation number 1, y squared plus 10y minus 24 equals to 0. So this is a quadratic equation. And the general formula for quadratic equation is ax squared plus bx plus c equals to 0. Here a, b, and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X it is actually equals to minus b plus minus square root of b squared minus 4 times ac over 2a. In our specific quadratic equation, y squared plus 10y minus 24 equals to 0, the coefficient a is equal to 1, the coefficient b is equal to 10, and the coefficient c equals to minus 24. So, and the variable that we are looking for is y, so x is equals to y. So we put the data inside the formula for x and we find out the value of the values of y. So x equals to y, so y is equal to minus b, b equals to 10, so minus b is minus 10, plus minus square root of b squared, b is 10, so b squared is 10 squared, that is 100, minus 4 times a is 1, times c, that is minus 24, over 2a, a is 1, so 2 times 1 is 2, so we got here that y equals to minus 10 plus minus square root of 100 minus 4 minus times minus 24 is plus 96. So it is, and 100 plus 96 is 196 over 2. So here we have two solutions that are possible for y. The first solution for y is that y equals to minus 10 plus minus square root of 196 is 14 over 2. So here we have two solutions that are possible for y. The first solution is that y is equal to minus 10 minus 14 over 2. Minus 10 minus 14 is minus 24. Minus 24 over 2 is minus 12. So we found out that y1 equals to minus 12. But here you can see in the drawing that y is side BD of the right triangle ABD. So y is a length. Y is a length, and therefore it must be a positive number. Therefore, y equals to minus 12 is incorrect answer. It is a negative number. So we'll focus on the second solution. That is actually y equals to minus 10 plus 14 over 2. Minus 10 plus 14 is 4, and 4 over 2 is 2. So we found out that y equals to 2 units. So I will draw triangle ABD in this new page. BD is y, that is equal to 2, and AD is x. So according to the Pythagoras theorem, we will get that the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The square of the hypotenuse is x squared, and it is equal to the sum of the squares of the perpendiculars. That is to say, it equals to 6 squared, that is 36, plus 2 squared, that is 4. So x squared equals to 40. We take a root out of this equation, and we get that x equals to square root of 40. 40 is 10 times 4, or 4 times 10, and the square root of 4 is 2. Inside the root we have square root of 10. So actually, we found out that x equals to square root of 10 times 2 units, exactly as we found in the first method. So we finished in the second method. In the next step, I will present to you how to find out the value of line segment x according to the third method. In the third method, we will define angle BAD as theta. We will define side BD as y. So here, if we focus on the right triangle, triangle ABD, in this right triangle, we know that tangent theta equals to BD over AB. BD is y, and AB is 6. So in conclusion, we found out that tangent theta equals to y over 6. In the next step, we will focus on the right triangle, triangle ABC. In the right triangle, triangle ABC, we know that tangent theta plus 45 degrees is equal to BC over AB. I'll repeat again. In the right triangle, triangle ABC, tangent theta plus 45 degrees equals to BC over AB. BC equals to y plus 10, and AB equals to 6. So in conclusion, we found out that tangent theta plus 45 degrees is equal to y, this will be equation number 1, y plus 10 over 6. And we have trigonometric identity. The trigonometric identity states that tangents 45 degrees plus theta, it doesn't matter. Okay, tangents 45 degrees plus theta equals to 1 plus tangents theta over 1 minus tangents theta. Here, tangents theta plus 45 degrees is absolutely equal to tangents 45 degrees plus theta. So we can use this trigonometric identity for tangents theta plus 45 degrees, and we substitute tangents theta plus 45 degrees by this trigonometric identity. So, and we get that according to equation number 1, tangents theta plus 45 degrees equals to 1 plus tangents theta over 1 minus tangents theta, and according to equation number 1, it is equal to 1 plus 10 over 6. We have already found out that tangents theta equals to y over 6. Therefore, we can substitute tangents theta in this equation, equation number 1, by y over 6. We do it now and we get that 1 plus tangents theta is y over 6 over 1 minus tangents theta is y over 6, and it is equal to y plus 10 over 6. Here we will divide 1 by 6 and we will multiply it by 6 in order to have a common factor of y over 6, and we get that according to equation number 1, six plus y over 6 equals to 6 minus y over 6, and it is equal to y plus 10 over 6. Here we have 6 in the numerator and 6 in the denominator, so 6 will get cancelled, and what is left from equation number 1 after we cancelled 6, what is left is actually, here we have 6 plus y over 6 minus y equals to y plus 10 over 6. Here we of course multiply equation number 1, and we get that according to equation number 1, 6 times 6 plus y is equal to 6 minus y times y plus 10. Here we'll open the brackets on both sides of this equation number 1, and we get that according to equation number 1, on this side of equation number 1, we have 6 plus 6 is 36, plus 6y, and it is equal to 6y plus 60 minus y squared minus 10y. So here we have 6y on both sides of equation number 1, so 6y will get cancelled, and we left only with 36. It is equal to 60 minus y squared minus 10y. Here we'll add y squared and 10y to this equation number 1, and we'll get that 10y plus y squared. We subtract 60 from this equation and we get that 36 minus 60 is minus 24. So we have a quadratic equation here. Y squared plus 10y minus 24, that is equal to 0. Actually, it is exactly the same equation that we got in method 2. So I will not repeat on the solution of the quadratic equation. We actually had two solutions here. The first solution is y equals to minus 12, but it is impossible because y is a length and the length must be a positive number. And the second solution is that y equals to 2. So if y equals to 2, then we have the right triangle ABD. We know that this is the right triangle ABD. We did it in the second method. Okay, I will repeat on it. This is 6. BD equals to y, that is 2 units, and this is x. According to the Pythagoras theorem, x squared equals to 36 plus 4. That is to say x squared equals to 36 plus 4, that is 40. We take out of this equation and we get that x equals to the square root of 40. 40 is 4 times 10. So x equals to square root of 4, that is 2 times square root of 10. So in conclusion, we found out that x equals to 10 times square root of 2 units, exactly as we found in the first method and in the second method. In the next step, I will summarize the lecture. Start with the first method. So we have here right triangle ABC. We know that side AB equals to 6 units, DC equals to 10 units, angle ABC equals to 90 degrees, angle DAC equals to 45 degrees, and we want to find out the value of AD, that is X. Okay, so we made a construction here. We extended line segment AD by a straight line, and then from point C we drew perpendicular to the extended AD. So this angle equals to 90 degrees and this angle also equals to 90 degrees. We define the touching point of the perpendicular from point C and the extended AD is E. Okay, so here we have then focused on the right triangle AEC. In the right triangle AEC, we know that the sum of the angles must be equal to 180 degrees. So which angles we have in the right triangle, triangle AC? We have here 45 degrees, we have here 90 degrees, plus angle ACE or ECE. In total, the sum of those two angles must be equal to 180 degrees. We subtract 90 degrees from this equation, and then we subtracted 45 degrees. We subtracted 145 degrees from this equation, and we found out that angle ECA, this angle ECA equals to 45 degrees. Okay? And according to the rule that we defined side DE as Y, and according to the rule that in front of equal angles in the triangle there are equal sides, so we have here two equal angles in this triangle AED, therefore in front of those two equal angles there are equal sides. That is to say, AE equals to EC. AE equals to EC, but AE equals to X plus Y. So from this equation, X plus Y equals to AE equals to EC, we derive that EC is also equals to X plus Y. Okay? And then we have the rule that vertex angles are equal to each other. Those two angles are defined as vertex angles, therefore they are equal to each other. So if one angle is alpha, then the other angle will be also equal to alpha. So in the right triangle, triangle ABD, we have one angle that is equal to 90 degrees. The other angle equals to alpha. So the third angle must be equal to 90 degrees minus alpha. And here also we have in the right triangle, the right green triangle, triangle EDC, we have one angle that is equal to 90 degrees and one angle that is equal to alpha. Therefore, the missing angle must be equal to 90 degrees minus alpha, because if you add those three angles, you will get exactly 180 degrees. 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees is 180 degrees. So this angle must be equal to 90 degrees minus alpha. So we actually found out that all the angles in those two green right triangles are equal to each other, and therefore those two green triangles are similar to each other according to angle similarity rule. Okay? Here, triangle ABD, the right triangle, triangle ABD is similar to right triangle, DEC according to angle similarity rule. And from the fact that those two triangles are similar to each other, we will conclude that the following relationship exists between the sides of those two right green triangles. We will conclude that AB over EC equals to BD over DE equals to AD over DC. Okay? AB over EC equals to BD over DE equals to AD over DC. AB is 6, EC is X plus Y, BD is BD, and DE is Y, AD is X is the missing variable that we are looking for, DC is, it is given us the question that is 10. Then found out the value of line segment BD. What is the value of BD? We have here, according to the Pythagoras theorem, in the right green triangle, triangle ABD, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, x squared equals to 6 squared plus BD squared, or AB squared plus BD squared equals to AD squared. Okay, AB squared is 36, or 6 squared, this is 36, plus DB squared is the missing variable, plus AD, this is x. So so AD squared is x squared. 36 plus BD squared equals to x squared. We subtracted 36 from this equation and we got that BD squared equals to x squared minus 36. We took a root out of this equation and we got that the value of BD is equals to the square root of x squared minus 36. So we can substitute BD in this equation, equation number 1, by square root of x squared minus 36. We did it and we got that according to equation number 1, 6 over x plus y equals to the square root of x squared minus 36 over y, that is equal to x over 10. Then from this long equation we created two different equations. The first equation is that 6 over y is equal to square root of x squared minus 36 over y. Here we cross multiply this equation and we got that 6 times 10 is 60 and 60 equals to x times x plus y. We open the brackets here and we got that 60 equals to x times x is x squared and x times y is xy. We subtracted x squared from this equation and we got that xy is equal to 60 minus x squared. So this is equation number 1. Then we created equation number 2 from this equation. And according to equation number 2, here we have equation number 2, that square root of x squared minus 36 over y equals to x over 10. We cross multiply the equation number 2, and we got that 10 times square root of x squared minus 36 equals to xy. Then we created equation number 3 that states that xy according to equation number 1 must be equal to xy according to equation number 2. xy according to equation number 1 is 60 minus x squared, and it must be equal to xy according to equation number 2, that is x times square root of x squared minus 36. We squared both sides of equation number 3 and we got that 60 minus x squared squared equals to 10 squared, that is 100, and here the square cancels the root and we left only with x squared minus 36. We open the brackets on both sides of equation number 3 and we got that 60 minus x squared squared is 60 squared, that is 3,600 or 3,600 minus x to the power of 4 minus 2 times 60 times x squared, and it is equal to 100x squared minus 100 times minus 36 is minus 3,600. Okay, then here we have 2 times 60 is 120, so it is 120x squared, that is equal to, here in this side of the equation we have 100x squared minus 3,600, and here in conclusion we got that according to equation number 3, x to the power of 4 minus 220, actually we subtracted minus 100x squared from equation number 3 and we got that minus 120x squared minus 100x squared is minus 220x squared. So in conclusion we got that x to the power of 4 minus 200x squared plus 7,200 equals to 0. Then we know that minus 220 is equal to minus 180 minus 40. So we substituted minus 200x squared by minus 180x squared minus 40x squared, and we got that x to the power of 4 minus 100x squared minus 4 t times x squared plus 7,200 equals to 0. Here we took a common factor of x squared from this expression, and here inside the brackets we will have x squared minus 180, and from these two expressions we took minus 40 as a common factor, and inside the brackets we have here x squared minus 80. So from this expression, we took x squared minus 180 as a common factor, and inside the brackets, we will have, from this expression is left x squared, and from this expression, it is left minus 40. After we took x squared minus 180 as a common factor, so here we will have two solutions that are possible for x. The first solution is that x squared minus 180 equals to 0, or the second solution is x squared minus 40 equals to 0. So in the first solution, x squared minus 180 equals to 0, that is to say x squared equals to 180. We took out of this equation number 1, and we got that x equals to 180. 180 is 36 times 5, so, and the square root of 36 is 6. So in conclusion, we learned that according to this solution, x equals to 6 times square root of 5, that is actually 13.416 units, that is greater than 10. And the second solution is that x squared minus 40 equals to 0, that is to say x squared equals to 40. We took out of this equation number 2, and we got that x equals to square root of 40. And 40 is 4 times 10, so in conclusion, we found that according to the second solution, x equals to 2 times square root of 10, that is 6.32 units, that is less than 10 units. Okay, and then I copied triangle ABD and triangle ADC in a new page, and here we have this is a triangle ABD, the other triangle, and this is an exterior angle to the right triangle, triangle ABD. And we know that the value of the exterior angle of triangle ABD, it is equal to the sum of the two angles that are not adjacent to it. And the two angles that are not adjacent to it is theta plus 90 degrees. Therefore, the value of the exterior angle ADC equals to 90 degrees plus theta. And we know that the sum of the angles in any triangle is equal to 180 degrees. And especially in triangle ADC, the sum of its angles must be equal to 180 degrees. So which angles we have here? We have 45 degrees, we have 90 degrees plus theta, and we have this angle, that is angle ACD. We subtracted 90 degrees from this equation, and then we subtracted 45 degrees, and then we subtracted theta, and in conclusion found out that the missing angle ACD equals to 45 degrees minus theta. This, the missing angle ACD equals to 45 degrees minus theta. And we have rule that in front of the shortest angle in a triangle, there is in front of the smallest angle in the triangle, there is the shortest side. And because of the fact that in triangle ADC the shortest angle is 45 degrees minus theta, therefore in front of this angle, that is to say AD, that is x is in front of the shortest angle. Therefore x must be the shortest side. That is to say x must be less than 10. Because this equals to 10, so x must be less than 10 units. So here we had two solutions that are possible for x. The first solution is that x equals to 6 times square root of 5, that is 13.416, that is greater than 10. So this solution that is impossible, it is incorrect, because x must be less than 10 units. And therefore, the only solution that is left is that x equals to 2 times square root of 10, that is actually 6.32 units. That is less than 10, therefore, this is the solution. In conclusion, we found out that the value of the line segment x equals to 6.32 units, so it is we can represent it also as 2 times square root of 10 units. So this was the first method. Then I presented to you how to solve the question according to the second method. In the second method, we did the construction. Actually, from point D, we drew a straight line on AC in such a way that angle AED will be equal to 45 degrees. So in triangle ADE, we have 2 angles that are equal to 45 degrees, and we know that in front of equal angles in the triangle, there are equal sides. That is to say, side AD must be equal to side DE, but side AD equals to x, so side DE also must be equal to x. Okay, and then we drew perpendicular from point E on BC. That is to say, this angle equals to 90 degrees, and this angle also equals to 90 degrees. And we define the touching point between the perpendicular from point E to BC as F. Okay. Then in triangle ADE, the right triangle ADE, we know that the sum of the angles must be equal to 180 degrees. So here we have in triangle ADE, the sum of the angles must be equal to 180 degrees. So we have here 45 degrees. Actually, this is triangle ADE. This is triangle ADE. In triangle ADE, the sum of the angles must be equal to 180 degrees. We have here 45 degrees plus 45 degrees plus this angle that is actually angle ADE. In total, the sum of those 3 angles must be equal to 180 degrees. We subtracted 90 degrees from this equation and we found out that the missing angle, angle ADE, is a right angle. It is equal to 90 degrees. Okay. Actually, it is given us the question that triangle ABC is a right angle and BC is one side of a triangle. Therefore, it is absolutely a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line BC at point D, the sum of the angles on the upper side of BC at point D must be equal to 180 degrees. Okay? But here we actually defined this angle is theta, and this angle equals, if this angle equals to theta, then angle ADB must be equal to 90 degrees minus theta because of the fact that the green triangle is a right triangle. And, okay, so we know that the sum of the angles on one side of the straight line BC must be equal to 180 degrees, so if we focus on the upper side of the straight line BC at point D, the sum of the angles must be equal to 180 degrees. So which angles we have at point D on the upper side of BC? We have here 90 degrees minus theta. We have also 90 degrees, and this is the missing angle. So 90 degrees minus theta plus 90 degrees plus the missing angle, this is angle EDF. In total, they must be equal to 180 degrees. We subtracted 90 degrees from this equation and we found out that minus theta plus angle EDF must be equal to 0. We added theta to this equation and found out that the missing angle here, this angle is equal to theta. So if this angle equals to theta, the green triangle is a right triangle, so this angle must be equal to 90 degrees minus theta. Therefore, we actually found out that all the angles of the two green triangles are congruent to each other. Both triangles have angle theta, both those two triangles have angle that is equal to 90 degrees minus theta, and both those two triangles have angle that is a right angle. Okay? And we actually proved that the two green right triangles congruent to each other. Why they congruent to each other? First of all, angle BAD equals to angle EDF, both angles are equal to theta. Then we know that AD equals to DE equals to X, and angle ADB equals to angle DEF equals to 90 degrees minus theta. Those two angles are also equal to each other, therefore those two triangles can go into each other according to angle side angle rule. And from the fact that those two triangles can go into each other, we conclude that AB equals to DF. AB equals to DF according to the rule that the corresponding sides in congruent triangles are equal to each other. But AB equals to 6. So from this equation 6 equals to AB equals to DF, we will conclude that DF also equals to 6. But we know that DC equals to 10, DF equals to 6, so FC will be equal to DC minus DF. That is to say, to 10 minus 6, that is 4. Okay, here. DC minus DF equals to FC, DC equals to 10 units, DF equals to F, DF equals to 6, so FC equals to DC minus DF, 10 minus 6, that is 4. So we found out that this 9 segment FC equals to 4 units. Then, because of the fact that those two green triangles can go into each other, we will conclude that BD equals to EF, according to the rule that corresponding angles in congruent triangles are equal to each other. We define BD as Y, and because of the fact that those two sides are equal to each other, EF will be also equal to Y. Okay, here. So, in the next step, we actually proved that those triangle ABC is similar to triangle EFC. Why those two triangle ABC is similar to triangle EFC? Because of the fact that angle ABC is equal to angle EFC, both angles are right angles. And they have angle that is a common angle. This angle belongs to both triangles. So they have two angles that are equal to each other, and the third angle will be equal in both triangles according to third angle theorem. The third angle BAC equals to angle FCC according to the third angle theorem. That is to say, if you have two angles in one triangle that go into two angles in another triangle, the third pair of angles must be also congruent according, because they must be complete the sum of the angles in the triangle to 180 degrees. They are complementary to 180 degrees. So we found out actually that the right big triangle, triangle ABC, is similar to the right small triangle, triangle EFC, according to angle similarity rule. Okay, and because of the fact that those two triangles are similar to each other, we conclude that the following relationship exists between their sides. That is to say, we conclude that AB over BC equals to EF over FC. AB over BC equals to EF over FC. AB is 6, BC is 10 plus Y, EF is Y, and FC is 4. We also multiplied this equation number 1 and found out that 6 times 4 is 24, and it is equal to 10 plus y times y. We open the brackets. Here, 10 times y is 10y, y times y is y squared. We subtracted 24, and we got that y squared plus 10y minus 24 equals to 0. We have here a quadratic equation, and in our specific quadratic equation, the coefficient a equals to b, the coefficient b equals to 10, and the coefficient c equals to minus 24. And we put the data inside the formula for x, and we got that y equals to minus b plus minus b is 10, so minus b is minus 10, and it equals to b squared minus 4 times ac. And we actually found out that the value of y, it is actually equals to either minus 12 or 2. But because of the fact that y is a length, it cannot be a negative number. Therefore, we left only with the solution that y equals to 2 units. Then we found out the value of x according to the Pythagoras theorem that we implemented on the right triangle ABD. Here, according to the Pythagoras theorem, x squared equals to 6 squared plus 4 squared. That is to say, x squared equals to 36 plus 4, that is 40. We took out of this equation and found out that x equals to the square root of 40. This is actually 2 times square root of 10 units. So in conclusion, we found out that x equals to 2 times square root of 2 units. We finished with the second method. Then I presented to you how to find out the value of line segment x according to the third method. In the third method, we defined angle BAD as theta and BD as y. And here we know that tan is theta equals to y over 6. And in triangle ABC, tan is theta plus 45 degrees equals to BC over AB. That is to say, BC is y plus 10 and AB is 6. So tan is theta plus 45 degrees equals to y plus 10 over 6. And we have the trigonometric identity that tan is theta plus 45 degrees equals to 1 plus tan theta over 1 minus tan theta. So we substituted tan theta plus 45 degrees by this expression, and we got that 1 plus tan theta over 1 minus tan theta equals to 1 plus 10 over 6. Then we substituted tan theta by 1 over 6 by y over 6, and we got that y 1 plus y over 6 over 1 minus y over 6 equals to y plus 10 over 6. And after we solved this equation, we got the quadratic equation that y squared plus 10y minus 24 equals to 0. And it is exactly the equation from that we already found out in the value of it in the second method. We found that this quadratic equation has two solutions. The first solution is y equals to minus 12, and the second solution is that y equals to 2. But because of the fact that y is a length, it cannot be equal to a negative number, so the solution y equals to minus 12 cancelled, and we left only with the solution that y equals to 2. So here we know that in this right triangle, BD, that is y equals to 2, AB equals to 6, and the hypotenuse is x. So according to the Pythagoras theorem, we get that x squared equals to 36 plus 4. That is to say, x squared equals to 40. We took a root out of this equation and found out that x equals to the square root of 40. 40 is 4 times 10, and the square root of 4 is 2. So in conclusion, we found out that x equals to 2 times square root of 10 units. So in all three methods, we found out that the value of line segment x is equal to 10 times square root of it is equal to 2 times square root of 10 units. That is actually about 6.32 units. Okay? I repeat again, the value of x is 2 times square root of 10 units, or in terms of numbers, it is equal to 6.32 units. Okay? Thank you very much.